Okay, so this is Unit 4, Concept 2, the electromagnetic spectrum, or the EMS. The EMS is a continuum of all the transverse waves that we know of that travel at the speed of light. Okay, so all of these are really light waves. They're just different types of light waves. Okay, so the first type, we are going to start at the left of this picture, and you have this in your notes. So what you need to do is make sure that you are labeling whatever that I'm writing down. Okay, so we're going to start with the first one on the left over here. The first type of EMS is, or the EM wave, is the radio wave. Okay, now we are very familiar with the radio wave because that is what we listen to. Okay, they transmit sound. They are also used to transmit a lot of different signals. Okay, now these are really, really long waves. Radio waves can be as long as a football field or even longer than that. Okay, the next one is the microwave. Microwaves are a lot shorter than the radio waves, but they're still considered pretty long waves. Um, Now, microwaves are, of course, used in the microwave ovens, but they are also used for transmitting signals. Next type is the infrared. They're a little bit shorter, okay, just a bit shorter than the microwaves, and the infrared waves are basically right outside of what we can see, okay? The word infra means below. So this is actually below red, okay? And what that means is it is basically right outside of the red wavelength. And infrared is used in a lot of our night vision goggles. So we can use infrared to figure out where we are detecting heat, and that way we can see at night where people might be or where animals might be. Okay, and then we get to the visible lights. Now the visible lights are basically white light, and if we look at white light and we split it up through a prism, then we get the visible colors. Okay, or Roy G. Biv. Alright, so what does Roy G. Biv stand for? R is for red, O is orange, Y is yellow, okay, G is green, B is blue, I is indigo, and V is violet. Okay, now indigo is just a color that's kind of a dark purplish blue. Okay, it's right in between the blue and the violet range. Now, the red waves are the longer waves, and the violet waves are the shortest waves out of the visible waves. Okay, so we can see waves that are in this range, and that's basically the limit of our sight. So again, the red waves are the longest waves, and the violet waves are the shortest waves out of the visible light. Alright, and then we get to UV, or ultraviolet. Ultra just means above, so this is above violet. Okay, so infrared is below red, and ultraviolet is above violet. Okay, ultraviolet is shorter than the violet light, so this is the part where it starts to be a little harmful. So these are waves that can be a little harmful. Okay, these are higher energy waves, and they are going to start to hurt living tissues. Okay, and then we have X-rays. Now we know X-rays are can cause cancer, so that is why we have to put on a vest that's made of lead to kind of protect us from the X-ray when we go to the dentist's office. Okay, and then finally we have gamma rays, which are the most energetic, highest energy, shortest types of electromagnetic waves, and they can be very, very harmful to living tissues. Okay, now what you will see is these waves that are on the left, starting with the radio waves, are the long waves. Okay, so these are long wavelengths. And so on the other side, with X-ray and gamma ray, these would be the short ones. So short wavelength on the right side. Okay. Now long wavelengths have low frequency. And so short wavelengths would have high frequency. Long wavelengths and low frequency waves also have low energy. And the short wavelengths with the high frequency also have high energy. Okay, so you gotta know which ones would have higher energy and which ones would have lower energy, which ones would have higher frequency, which ones are lower frequency, and so on and so forth. Okay, so make sure you know this pattern and make sure you know the order of the electromagnetic spectrum. Okay, all electromagnetic waves travel at the speed of light. Remember, they are really just light waves, just different types of light waves. Okay, now the speed of light is c, or we use c to symbolize it, and c equals 3.00 times 10 to the 8th power meter per second. The longer wavelengths equals lower frequency. We already labeled this in the picture, but let's write it down in words, okay? And also lower energy. Okay. Shorter wavelengths, on the other hand, would have higher frequency and higher energy. Alright, now let's talk about what frequency is, okay, because this is kind of a new thing. We talked about wavelength before, we know what energy is, but we haven't really talked about frequency of waves. Frequency is symbolized by the little letter F, okay, and frequency is basically the number of waves that pass a point in a set amount of time. Okay, so it basically is the number of waves that go through in an amount of time. And this is usually measured in hertz. Okay, and we use capital H, little z, to symbolize hertz. Okay, now really hertz is just the number of waves over seconds. Okay, so hertz is the same as 1 over seconds. Alright, so let's look at some examples. Which wave has the longest wavelength, red or ultraviolet? If you have to turn to the picture, go ahead and do so. Okay, and you should be able to see that the red waves are the longer wavelengths. Which wave has the lowest energy, radio or green? It will be radio. And the last one, which wave has the highest frequency, microwave or X-ray? This one would be X-ray. Okay? So again, make sure you know the order of the EMS and make sure that you can answer the types of questions like these examples.